Hi everyone. Good morning, good afternoon, good evening, based on the time zones. And guys, before starting the session, can any one of you give me a quick confirmation? You can see my screen and hear me as well. Great. Thank you for the confirmation. So my name is Sham. I have been working with IT industry for close to 10 years now. So before I start, let me share our Edureka masterclass community with you all. So right now what I'm showing, what I'm projecting is Edureka meetup, wherein this is a kind of community of masterclass we started back in 2019, and since then we have been closing into almost 30,000 members so far. And about in these masterclass we published more than 100 webinars and live events on different topics like IoT, big data, RPA, AI, ML, PMP, and multiple backend and front end based technologies like Java, PHP. All those technologies we are covering in the webinars, so that we all should be aware what all technologies are going on. And the best part of these trainings from Edureka is these webinars are absolutely free. This platform will help you to give a direction the way you want it to get started and achieve your goals and to reach the destination organizations. Basically, you will be notified. The best part is, why to join this group is you will be notified about the scheduled recordings. I guess most of the members already have been enrolled and they're benefiting about these from Meter platform. So we'll start. What is artificial intelligence? That's a word which is from past from 5 years that's been into more into the IT sector. It is going into picture. So artificial intelligence, it was introduced late back in 1956, 1950s. But what exactly it is? Artificial intelligence in the technology, in the computers. Basically, it's a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that require typically human intelligence. So, in a nutshell, I can say simulating human intelligence in machines. That is all about artificial intelligence. So example, I can give you some of them. Speech recognition, which we can see in our environment right now. Everything, you say, we have Siri, we have okay Google, all those platforms which are indirectly or directly using AI platforms only. Problem solving skills, you can make your model learn about these kind of aspects, and so that it, if you train someone to do a repetitive job or a sensible job as well, so AI model is capable of doing catering this particular solution. And learning and planning as well. Learning and planning, when I say, we have a very good example of planning is, there are some project plans which you build up. You feed some of the from past, how many, I guess so many projects we have done till now. You feed all those models into this particular AI platform. You will be able to from the inputs which you provide, you will be able to predict that this particular project, how much time it will take, including if all the the session, the phases of the project model. Either it's a software development life cycle, or else it's a normal projects which we use in any of the industry. Okay, so we're giving you some of the examples. It's like Siri, iPhone. I mean, everyone is using. If someone is having, Apple iPhones, and have Siri and OK Google are using this artificial intelligence. Whenever you ask some questions, you schedule some of the meetings, you set an alarm, your sleeping time, your a basic methods, which all those things, that data is getting captured in your phone itself, based out of which prediction technologies goes on. Then we have Tesla, like autopilot mode in cars. Cogito is a company, provides a real-time guidance to the customer. Believe me, this platform is like uh, they're giving 70% of the customers based on AI. They're giving answers over the call, and they're giving accurate answers to the customer, and nobody can understand the human is speaking or artificial intelligence models are speaking those answers. Netflix recommendations based on consumers' reaction, interest, choices, and behaviors. This is also part of AI. Then we have multiple examples: Pandora, Nest, flying drones, Eco Dot. You have heard about Amazon product to schedule appointment, control lights, answers questions. All right, so let me quickly jump out to this. I mean, what all agenda we will be covering today? That is introduction to artificial intelligence. Why Python for AI? Features of Python, Python packages, and we'll be covering some of the hands-on examples as well, wherein we'll show how the data modeling can be done, based out of which you can do some predictive analysis as well for the data which is already present in the market. So before we start with the particular agenda, I would just wanted to segregate differences, or else between, most of the people are right now confused what is AI, what is ML, what is deep learning. So setting this ground rule, that is, AI is a science of getting machines to mimic the behavior of human. That's a AI. Mimicking, you can say, a straightforward mimic is directly proportional to the AI. Then we have ML. ML is basically machine learning subset of AI that focuses on getting machines to more decisions and feeding the data. You feed the data, and there is data modeling goes on. I mean, the very branded example I can say now, that's a Apple example. You feed 1000 colors of apples to this machine learning models, then whatever you feed to the machine learning models, it will be able to predict it's an apple or it's an guava, it's any other fruit. So based on the data which you have given to the machine learning. So there is no, I mean, I'll tell you, like, machine learning is not having something which uh, automatically it is enhancing the skills, it is taking up the decision. Whatever you are given to the machine learning models, that only it is able to capture and give you a predictive results. And there is another term, deep learning. Deep learning is basically a subset of machine learning only, that uses concept on neural network and solving a complex problems based on some mathematical rules, which having Python in our technologies which we have right now, NumPy, which is array based calculations based out of the climate take or stock market, whatever the data has been fed. Okay, introduction to artificial intelligence. I guess I have covered most of the things on what is artificial intelligence. So I mean, I'll go with this particular model. What is, why there's a demand of AI. So right now, if you see, there's there is terabytes of data, gigabytes of data, which is flowing in a seconds, a fraction of seconds. So you can see, like, how much data has to be evaluated, how much data has to be processed to get a meaningful information in seconds of timelines. That's what there is a demand of AI. And we are in AI, we are talking about, not about talking about CPU, we are talking about GPU here. So if you have to model something, you have to create some model, you have to feed the data, you have to thousand crore of data you have to feed to some of the models, and then you have to be able to get the data outside that. So in this particular scenario, you will be able to compute data in fraction of seconds by using GPUs. Then better algorithms by using Python. Python is having, right now we'll be covering with more more libraries like NumPy. We have Matplotlib, multiple libraries which through which we have a better algorithms. No need to write the code. Thousands of lines of code already been built up for you guys, and you have to just plug and play. And broad investment, more data, big data. Big data is something, you are calling to someone, even that is a mean, to whom you are calling, how much, what is the frequency, based out of which you'll be getting the packages as well as an offer from telecom sectors. These are the big data analysis has been done. Okay, what is AI? Have covered with that. So we have a pillars for AI. I'll go one by one, for all the pillars, what exactly the machine learning, deep learning. I've given you, the basics of machine learning, but I'll still, explain you what is machine learning. Okay. All right. So basically, in artificial intelligence, if we talk about any algorithms, it's a sequence of statistical data processing steps. So if you want to make some decisions, you have to write an algorithm. and you have to train to find the patterns and features in massive amount of data. Like as I given example of apples, if you feed green apple, red apples, all those things. I mean, if you feed like thousands of apples colors to one particular model, the machine learning models are so super fast, resilient, that it is able to predict the future. I mean, what all things can be predicted. And it's basically a branch of artificial intelligence itself, and focused on building application that learn from data to improve their accuracy over the time without being programmed or do so. So it's like, mean something. If I give you a real time example, so I'm talking about JP Morgan. So JP Morgan used to spend 36,000 hours of employee time just to figure out what is written in the particular sheet, or PDF files, a kind of invoices they were having some POs and POs and PO orders they were having. And based out of that particular machine learning models they have given training to close to samples close to I guess from 1000 3000 models they have given, how the invoices will be looking like. Now they are able to process close to 70,000 records of PDF data, that are scanned images, basically scanned images having there is OCR technologies which is revived, integrated, and also along with that there is analysis on the basis of where are the details written, who has written those details, and on those basis they are able to extract the data and insert into some of the ERP system to get the data in particular manner. And the main thing is not only saving 36,000 hours, that is also if you take data from somewhere and if you write in the system, it's a tedious job to do. And and even there is a spelling mistakes, errors, all those kind of things gonna happen. But now they are getting accuracy of 99%. That's a commendable the machine model example which right now these companies are using. Then we have NLP. NLP is I'll give you an example. Like if you write some emails right now in Gmail, there is a spell checker, there's autocomplete, spam filters, uh, voice text messaging. Also, there's a features of these are all natural language processing. So how, I mean, this is a branch of artificial intelligence itself. Many of us are using NLP on a daily without realizing. Like you have probably used at least once, in all those tools right now, which I told you example. And I'll tell you, like in artificial intelligence, how it is used is when you're writing some email. So it's not only how you are writing. It's tons of data, mails which are getting exchanged on a daily basis. From those only, it is Gmail is picking and doing some processing has been done for the natural language. And how the people of which region are writing. UK has different aspects of writing, US has different aspects of writing, is able to process, and computer is able to ability to read and understand, to interpret human language as well, now through this particular NLP as a tool. Then going to deep learning. So I'll explain you, like I mean how deep learning is also evolving in some certain criteria. Deep learning is uh, in AI. I told you, like there is machine learning, then also deep learning is going and evolving. So deep learning is a subset of machine learning only, in which multi-layered neural network model to work with human brain and learn the large amount of data through this particular deep learning aspects. And deep learning, I can say in a nutshell, it's a kind of simulation of human brain, how you think. So based on the modeling, uh, let's take an example. Today you are telling the model that is A plus B is equal to C. So you can have some permutation combination, that is called as machine learning. Now automatically there will be a predictive analysis by AI and deep learning together to get multiplications as well, division as well, and there can be another introduction as well, from that is from the AI aspects. So that is how without human intervention as well, automatically through deep learning, the accuracy of the model which you have trained in machine learning, if you engulf deep learning, it will be able to increase the accuracy based on objects and complexity task whichever you have provided to that particular model. Okay. All right. So going to the another topic, that is computer vision. I'll give you only two liners or three. That's computer vision needs even it's all about data only. Machine learning, NLP, deep learning, computer vision, all about the data itself. So, but that's it. Computer vision only runs. It runs on analysis of data over and over until it discerns the distinctions of ultimately recognizing images. Basically, I'll give you a very good example here. If you watch some of the movies, if you watch some of the videos in YouTube, maybe the name is different. So, but also if that computer vision is enabled there, automatically the images are getting captured. Like maybe you like some Bollywood star, you will like some Hollywood star. You will be able the computer will be able to extract the information based on the pixels, and it will be able to give you a recommended solution on so basically recommended solution or recommended results, whom do you like, and based out of it you will be able to get some more videos. That's a basic example. And so basically if I talk about that Apple example, the favorite example of all machine learning and AI person, that is to train a computer to recognize one apple. So it needs to be fed vast quantities of Apple images and Apple related to items and learn differences on recognize the apple, so that if someone is getting some other region apple, so it will be able to identify what particular region is also it is stating, so that there's one to one or one to many mapping as well. Okay, all right. So that's the main more basic four pillars are there. The knowledge base is something which we have already in our system, in which if you are training someone, you are creating some libraries as well, and also you are creating a good knowledge base. So it's like you have some inference system, and so it's a kind of intelligent, there is environment, and then the inference engine is there, so that there is a knowledge base based out of which you are able to make the machine learns. That's how the knowledge base works. That's a repository kind of method, you can say, so that they're maintaining on internal state of knowledge, reason over that knowledge, update their knowledge and observations, and how they have to take the actions based on this knowledge base. Okay, all right. So I think these pillars are fine. There is last pillar, that is expert system, in which basically it comprises of the system in which we again it's artificial intelligence itself, and an expert system incorporates a knowledge base containing accumulated experience of an inference rule engines, how machine learning can also be trained, and how if something is repetitive, how it can be um trained to this particular model, so that it can simulate a judgment and behavior of a human or an organization that has expert knowledge and experience on the particular field or particular domain. Okay, that's introduction of artificial intelligence when it was done it through from John McCarthy, and he only introduced artificial intelligence at a term. That was a time in which nobody had predictive. So, but now we can see there is most of the systems which we are using as artificial intelligence. Okay, so now we have types of AI. So there are some types of AI. There are three types of AI basically: artificial narrow intelligence, then we have general intelligence, and the other one is super intelligence. So basically, I mean, right now I'll say narrow is something which we can say it's a basic level of intelligence. It is also called as a weak AI, that involves applying AI only to specific tasks, a limited predefined functions, even no genuine intelligence or self-awareness, despite of being sophisticated. Example, I can give you some of the examples which which you can relate in the daily life. That is face verification in iPhone. That's a weak AI. On so if you have seen that particular model which basically Steve Jobs and the owners of Apple have guided with machine learning technology which they are using. They're using a very small sector of the AI in which face is verified based out of your um, your pixels of your face, and that is based on a dot mechanism. And there is autopilot feature, social humanoid. If you have seen, if you have heard about Sophia, from, I mean, that's a Sophia bot. That is a weak AI is basically example. Google Maps, Google gives some of the suggestions. There is some, sometime Google Maps also irritates, how which basically route you have to take to reach to some destination. So that's basically, narrow intelligence, which currently we are in current environment. But second thing is, general intelligence, that we can say the strong AI that involves machines possesses with, ability to perform any intellectual task that human can. Right now it's a kind of solving riddles. And the other example is playing chess. There are some of the models which have already been developed. Even if you play some of the games, on the daily basis, whatever games you are playing, whatever inputs you are right now doing, based out of which the data is going and feeding into their database. And they're even, data analysts who are sitting on the other side, they're even watching the data, like which particular stage the user is getting failed, for 4 times, 5 times, based out of which they're even changing the game's algorithms, so that you do not lose the interest and you play the game again, because they are getting profit for by you are downloading their app and you are seeing the advertisement on in their app. So, I mean, I'll tell you one quote from Stephen Hawking also said, so right now, strong AI would take off on its own, like human will be superseded just because human involvement is only done on the basis of biological updates. If you wanted to update from yourself, that's human is going phase by phase, and every 10 years there is some other brains. If you see right now, if basic example, layman example, that's the kids right now, they're using phones as well. So that's how it is changing human involvement. But sooner, AI will be superseding all those aspects. So that's, general intelligence, which is right now we are introducing, still on a very, a basic stage, which we say. And the third one is, artificial super intelligence. If you talk about, that's more or less time when the capability of the computer will surpass the humans. So it's a kind of hypothetical situation, I can say. And it's only depicted on some of the movies. If you see some of the movies in some Hollywood movies or some Bollywood movies as well, there is some artificial intelligence which can supersede human brains as well. So that is a artificial super intelligence. Okay, so our main target, that is why Python for AI. So I mean, there are a few of the things which Python, why only Python we are using. So first of all, less code, from the previous legacy technologies. For even for doing one task, you have to write 10 lines of the code, but right now it's only extremely less code. You have to only focus on your algorithms, the first point. And Python has pre-built libraries like NumPy for scientific computation, and for SciPy for advanced computing, and PyBrain for machine learning. These are the already given pre-built libraries which has been developed by some of the some of the um, Googlers or some of the hits, and already they have introduced these libraries. You have to just simply use their libraries and get set go. You are ready for your pre-built models. I'll show you the example, live example as well. And Python is also a platform which independent, and hence one of the most flexible and popular choices for use different platform technologies. I mean, so basically, if you are coming from different background of the coding, so it's you are a very guide track, because now you need not to worry about the coding basic syntax, because Python is extremely easy as compared to the previous models. And also, Python is platform independent. I'm using Mac, you can use Windows, all those platform independent. So Python is also flexible for all others, with options of choose between, we wanted to choose object-oriented programming language approach or else scripting based, because why I'm saying this is, there are two types of terminologies here: object-oriented programming language, another is scripting based. So some guys are who are coming from the background of JavaScript and jQueries, Angular JS. I would suggest, I mean, they can directly go to scripting based methodology in Python as well. It will be easy to transition in this particular manner. But somebody who's coming from the Java background or totally in .NET background, then choose a OOPS approach, that is object oriented programming approach. Then Python is having a massive community right now. I mean, there's a huge community, as you see, of Edureka community as well. Here also, it's a work like the same, but more or less, you can use Python developers around world provide you comprehensive support and assistance. I mean, believe me, I mean, you write some of the queries, you'll be getting answer in another 10 or 15 minutes maximum. Anyone will be able to reply you and solve your queries. That's how the massive community is working right now for the Python. Okay, all right. So Python packages, I mean, today I will be covering some of the packages, what all has been used, what all we can use for the Python packages here. So that a package is something, I mean, it's like package is already a developed code which you have to use as a plug and play components. So it's a kind of reusable components. You have to pass some of the parameters, you have to remember some of the functions, you have to pass the parameters based out of which all algorithms are written in this particular packages, and you will be able to easily use. Okay, so the first package I will be package and library are the same thing. Do not confuse on these two terminologies. One is what is TensorFlow. TensorFlow library was developed by Google in collaboration with Brain Team, and popularly for machine learning algorithms, again the subset of AI itself. And currently, TensorFlow is the most famous deep learning library in the world in Google TensorFlow. So what happens is, to give you a concrete example, Google users can experience a faster and more refined the search with AI. If the user types keyword a search bar, Google provides a recommendation about what could be the next word. That's how and that's a TensorFlow beauty only. So currently it is using it as a TensorFlow mechanism itself. You write something, what is this? You will be able to. I mean, sometimes you have observed like, yeah, this is what we want. I mean, they are giving as a results. So I'll go you one by one, all those things. So Google wants to use machine learning to take advantage of this, massive data sets. So we have three different groups in machine learning. One is researchers, then we have data scientists, then we have programmers. So researchers who research, what all data we are getting, and based out of which they are feeding to data scientists, and the programmers are basically giving a proper coding mechanism to that particular search, and you are able to then get the examples on this particular search results basically on, and yes, basically on the basis of search engine optimization as well. That's another technology. Okay, so how the TensorFlow architecture works, I'll give you on, it's a basically a three layered model, in which there is one is pre-processing of data. What is pre-processing? Pre-processing is basically you get some heterogeneous data. You get some data of, let's say an example, cars. You get Toyota, you get BMW, you get Audi, you get Hyundai, all those data you get. And you pre-process these data, what exactly you need. You have to first write your problem statement. So your problem statement can be maybe your organization is predicting like Toyota will be doing a great job in 2025 based out of which parameters. So you have to pre-process those parameters. Maybe they have more multiple units, maybe they are collaborating with Maruti, maybe they're collaborating with another one, and they have a very good projects. You all have that particular data, and then you can go and confidently tell to your management, see boss, this cannot be happen based out of this particular data. So either you have to change the plan, either you have to change the strategy, but we cannot predict on these basis. And this predictive analysis is so important for the stock exchange as well. They're based out of those mechanism only. Stock exchange also works, and you have to invest or you do not have to invest. So these TensorFlow, right now it's being worked here. The other I mean, I told you the first one is pre-processing of data. The second one is building the model. The model which you create, you align the data, you separate the data of Toyota, you separate the data of another companies, you see the projection of the data, all those things in a building or a particular model, and then you have to train and estimate the model. Training in every machine learning and AI model, training is an extremely important part, because each and every model which you develop, what you have to get the output, one by one you have to go use this particular library and see from your training results for the particular, let's say an example, we have 60,000 or 1 lakh records. You cannot do analysis on all 60,000 records or 1 lakh records. So you choose some of the data, like say 1,000 records. You do some analysis on random 1,000 records. Then you impose all those random records to next 60,000 records to get a particular resultant. That's it is called as TensorFlow because it takes input from multi-dimensional array. And array is basically a kind of numpy, you can say, and numpy in Python, in which there is a array in which there is some computational going on, and those basis you have to pass some of the numeric data, and that is called as tensors. In this specific tensor architecture it follows. All right, so I think TensorFlow is majorly into why this has been used. TensorFlow is because the tensor goes into the flows through a list of operations, and then it comes on the other side to predict the data, what can be happen and what strategies has to be taken in another place. Okay, and then I mean the most important, it can be again the platform independent. It can run any of the OS, but the only thing is should have a memory of at least 4 GB RAM, and a basic qualifications to have run the software. All right, and going to the next top. Okay, so these are the features: responsive, flexible, easy trainable, parallel neural network training. Okay, so now next library again, and this is scikit. It's a scientific kit, in which again it's a library which you have to use as an import package in Python, and basically unsupervised learning algorithms and cross validation. I'll give you a very good example here. Supervised and unsupervised. I'll give you one example. Supervised learning is basically, uh, let's say, an email which you're receiving on a daily basis, and in the email where the amount is written, where the total amount is written, where the name is written, where the credit and debits are happening in this particular email body. That is, a structured format which can be trained to the supervised model. But what about the unsupervised learning algorithms? In which maybe you're not happy with some of the organization, you're not happy with some of the services. Let's say an example of any XYZ e-commerce company. You write some email. So on a daily basis, how many emails they are receiving as a negative or positive feedback? Millions of emails, and they cannot even hire so many resources. So these models are helping for just taking these particular emails, reading one by one, analyzing what exactly the problem they are facing, and how many people are basically in the angry mode, how many people are giving a good results, based out of which they are able to change the strategy as well, like they have want what part they have to enhance for the organization. So basically whatever you can done, I mean you can do for multiple packages. Only feature of scientific kit here is just because you have to extract some of the details from any of the unsupervised model, you will be able to do from this particular library. And also if I want to define something, so if your this sklearn library contains a lot of efficient tools for machine learning, and including classification, regression, clustering, and dimensionally reduction. You want to do all those things, then you can use all those this particular library. So majorly, I mean, which is already written, you can use for the cross validation. What is cross validation? So basically, there are various methods to check the accuracy of supervised models or unseen data. That can be done from here. So if you want to check accuracy, what is accuracy? Basically, in terms of I spoke about some example of the email. So if you're extracting the data, amount, the name, the last name, all those things can be done from this particular cross validation itself. It's a kind of validation, and another thing is peer validation. So that is done by this particular model library. Then we have, feature extraction. I was telling, that can be done, features from the images. Even you could do from, from the words you can extract, even from the images also. You can extract from the features. So somebody has the box, or, I'll give you the best example. There sometime it happens, you receive some of the delivery box from Amazon or any other big e-commerce site, and the product is different from whatever you ordered. Then you uh, give the image to them, and they evaluate those images. So that is all done by these current particular libraries only, and 70% times the data is accurate, and they're able to replace or return whatever items they wanted to do based on your need. And there are multiple data sets as well. They came in handy while learning scikit-learn. I had there are some SAS academic data sets. There are Boston House. I'll give you the example of Boston House kit. By doing the coding itself, I have the ready model itself right now, and having them handy while learning these libraries. And when I was talking about the unsupervised, I just wanted to add one more thing. In the unsupervised, all things can be happen, like starting off clustering, factor analysis, principal component analysis. All supervised, unsupervised, can be done through this particular kit. Then we have NumPy. NumPy is a library in again used for scientific mathematical data, but only point to be noted in NumPy is NumPy is only used for mathematical data. So no objective data is being used for, in case of NumPy. It supports uh, 2D, 3D kind of data. 2D is something array, there is multi-dimensional data which is being handled by this particular NumPy. But for an example, I can give you the climate, the stock data, exchange data, predictive analysis from past 10 years. That can be done through the NumPy itself. So basically, NumPy stands for numerical Python. Is a library consisting of multi-dimensional data objects and collection of routines for processing those arrays. And using NumPy, mathematical and logical operations on arrays can be performed by using only a single method. So you have to just learn, like you have to do sum, you write sum, you have to do multiply, write you have to write cross or something. There are some methods which is readily can be used easily for these statistical manipulations. And I think that's it. That more or less, I mean, all mathematical operations can be done where whatever you can, yeah, see whatever you can see, like if there is four sets of data, you can count, right? If whatever you can count, whatever you can you can do some sigma operations, square root, all those things which you can do and get some results. That all can be done through the NumPy itself. Then we have the last library introduction, that is Theano. So Theano is also a Python library that allows us to evaluate mathematical operations, including multi-dimensional arrays, so efficiently. And it's very easy to install. Just write pip install Theano. You will be able to install this particular library. And why Theano has been used, I mean, there are some of the points which are already written: tight integration with NumPy, transparent use of GPU. Basically, I'll tell you, I mean, if you want some stable optimization of your solution, you can find out some unstable expressions and can be used in a more stable form to evaluate them. Basically, we are getting some data from different vendors. So let's take example. I'm right now doing invoice analysis from different companies. I'm writing customer ID, the other vendor is writing ID, the third person writing employee ID. So if you want to do stability optimization, then you can use Theano as a Python library. And then if you want to execute, so as mentioned earlier, like Theano, we can so most recent GPUs which we are using. So if you wanted to execute the expression in your CPU or GPU, it is much faster than Python. And symbolic differentiation is there. So it's smart enough to automatically create symbolic graph for computing gradients. Even I'll tell you what is a gradient. They have a subset of examples where what is exactly the gradients. And so they basically, Theano is a Python library that allows you to define, optimize, and evaluate mathematical expression involving multi-dimensional arrays efficiently. Some of the Theano example, I'll tell you in the later stage. of this particular. So these are all, libraries. I'll tell you, like Keras is the same, having some additional features on this. If you wanted to do some graphical representation, you want to visualize something, wherein you can show like what x-axis is, what y-axis is, and it also handles with the API. So high level API handles we making models, defining layers, or set of multiple input and output models. So Keras also compiles a model with loss and optimizer function. So what is loss and optimizer function, which I'm quoting right now? That's so every model right now, whatever you predict, so there is some loss percentage. Even if you take an example, if you're some computer background, so whenever the data transfers to one place to another place, from one server to another client system, there is some packet loss. So we always create some loss percentage as well. So no data can be accurate. That is, all those. You see all the standards. Never we never say 100% data was accurate, because there is some error which is already in all the systems. Maybe some integration system, maybe some of the other ethic which has not been followed. So that is the loss percentage we keep. Whenever we have to analyze the data, we have to train the model, then you have to keep this loss and optimizer function. So loss, I told you. Another is optimizer is something, we have some of the algorithms by which you can optimize your solution. You need not to write that particular algorithm optimizer. There are some optimizers based on your model. You have to use those optimizers. Then we have computational graphs, which make tensors or variables, because it has been handled in a backend engine as well. So basically, what happens is, if you so the management does not have time to see all those data whatever you're giving to them. They wanted to see what exactly how the graph is performing, how we can take the action steps. So this is a kind of a differentiation which Keras made. There is another is matplotlib as well, which is doing the similar kind of thing, but this is having a high resilient, how Python is growing day by day. So there is a lot of introductions which is having. So need not to worry about these libraries. There is only thing is, we have to just see how the function has been used. Already our algorithms people have already written. No need to worry about those things. No invention needed here. Only thing is you need to write. You need to just expose. You have to just to call those functions. And I'll tell you one of the some of the differences between also from what is Keras and TensorFlow. So the purpose of Keras is rapid deployment for making model with standard layers. And there, if you wanted to use TensorFlow, then it allows you to make a arbitrary computational graphs or model layers. So if basically Keras gives you exact what exactly the methods you can apply here, which TensorFlow doesn't. All right, then we have our last library, which is NLTK. Then we switch on to the coding part. NLTK is study of natural language text analysis, sentiment analysis. I guess we already covered this. Wherein I'll take again example of Twitter. How Twitter. I mean, if you guys think how Twitter is removing a lot of posts on a daily basis. Daily basis 300,000, if you calculate, 300,000 of posts are being deleted from Twitter, just because of this particular technology. If you're writing some terrorist based what we say, some post is there, or else something related to religious which is not acceptable with any of the government. So this is a kind of technology which is helping a lot. Even they are able to remove the images as well, which is not fruitful for any of the social networking websites. So NLTK is a leading platform for building Python programs to work with human language data. It provides easy to use interfaces, and if you wanted to such as WordNet, along with suite for text processing libraries, classification, tokenization, and parsing the data, getting the resultant of the data. How I told you the example of how people reaction is if you launch some product in the market, and you launch the website as well. They're writing something, that's fine. I mean, that is fine, completely fine. They're writing something, maybe some other language. So what NLTK does is it creates one platform, creates into one language, their computer language, that is bytes language, and then they're able to judge the customer is happy with this product which we have launched, or else we have to improvise in any of the sector. So NLTK has been called as a wonderful tool for teaching and working in computational linguistics using Python, and an amazing library to play with the natural language. So that's it, from the NLTK side. All right, let's get started. The screen which you can see right now, that is of Anaconda. Anaconda is basically, just for beginners, Anaconda is basically a platform, a framework on which the Python is deployed, a Python code you can write. And it's extremely easy to download Anaconda. Just go to Google and click on the Anaconda download, whatever system you are having, Mac or desktop, as a Windows or Windows 10. You can download it, and once you download, there is other option called as Jupyter Lab. You have to click on Jupyter Lab. I'll show you like how you can see the screen. So once you download this Anaconda Navigator, you will be able to see Jupyter Lab notebook. So I mean, for this particular purpose, we will be going Jupyter Lab. That is an extensive environment in which we write all Python code, in which even all those libraries which we have discussed right now, that can be imported, and you have to just download and install it. Once you install this particular package, you have to just go on what, depending upon your need, you keep on installing, and then you can use depending upon your demand. Okay, so okay, we'll go through this particular model, that is MNIST data set. So basically MNIST, what is the case study? Basically, MNIST study, MNIST database is a database in which 60,000 training images have been calculated, in which they, wherein we have taken 10,000 testing images. We are taking 10,000 testing images, and our case study is to allocate one image type with one label. So that is a kind of repository, the case study which you are building. So just to give you a background, basically, the MNIST, which is the word which you can see, even you can search it on Google as well. That's that's a MNIST database. That's already handwritten digits available from this page, and has a training set of 60,000 examples. So basically, the database is already ready with us. So we are just doing on this particular model to will train 10,000 models. Automatically, it will be reflected to next 50,000 models. So that's how idea is to give one-on-one mapping to one image to one label. So let's say, so I'll show you like that. So if you see this particular image that has been mapped for 8,000, if you see 8,000 here, 8,000 have got this particular image. So now this particular image is allocated to 8,000 only. We'll go one by one how we have done achieved this particular model, and how the AI model has been trained, so that each and every number will be having a different image, and how what accuracy we are getting. So okay, so we'll go one by one. One is we have first of all getting TensorFlow version. We have 2.x. That is, there was one version for 1.x, 2.x. There is no very great difference between 1.x and 2.x. That's the major thing which they have achieved in TensorFlow 2.x is, if you can see TensorFlow.keras, that is a kind of the intercoupling or tightly coupled they have done for two particular package. There is one library, another library, they have packaged all together both. Okay, we'll go one by one. First of all, we have imported TensorFlow, and whatever version you are using, just write the version here. You'll be getting output as 2.3, just for our sake, which version you are using first. And then you have we have initialized a random number generator. So basically, we have written random dot seed 0. What is seed? I'll make you understand what is seed. The seed is the starting point of for the sequence, and guarantees that if you start from the same seed, you'll get the same sequence of numbers. So if you see random, if we do not define this, then what's going to happen, if you run the same code on your machine, there will be some different type of models. To set the standard, we have to define, like, for each, maintaining the consistency for each of the machines wherever the code will be deployed, will be having the similar kind of results. We have to define seed.0. Then we have ignore the warnings. That is, we are ignoring the warnings. Maybe there are multiple warnings which you will be receiving that we are currently ignoring because we do not want this. Whenever you load a data, there are multiple pixels going on. Now we are analyzing close to 10,000 testing images and having a lot of images pixels, and we want to ignore this. That's what we are using this. Let's load the data set. So first what we're doing is, um, we are the syntax. First of all, TensorFlow, Keras, or data sets. Why we using TensorFlow and Keras is basically, Keras is for this particular model we need both the packages together. So that's what we have used TensorFlow.keras.dataset. Dataset is nothing but data tables, because now there will be pixels formulation. There will be a set of basically tables which will be used to manipulate the data and to assign each data to one particular image. So one is, I mean, this is a form which we have to raise, x train and y train. So what exactly it is? X train and x test is basically a grayscale of RGB codes from ranging from 0 to 255, and where y train and y test contains the labels from 0 to 9. So we have 10,000 records, but in binary, if you see, there is a combination 9,000, 60,000, 40,000. That will be in between 0 to 9 only. So that's what we have to use. And then what we have done is we have loaded the data. So there's a minutes data which we already defined, and we have used a function which is already present in TensorFlow library. That is load data. We're loading all the data there. Then we have we have to visualize data. So as I mentioned in this session as well, like there is a library which is called as matplotlib, and .pyplot is basically library function is there which we have using here to visualize the data. If you see this image, this, if you do not use this matplotlib, you will not be able to see this particular image. And then we have, we are just printing. So print is nothing, it's whatever you see here, matplotlib.image x image at this particular grayscale number they have given, that is coming from the print command basically. And then there plt img show x train, and we have grayscale. We want to the gray model here, so that is a black and white combination. That is how we are giving cmap as gray. So this is basically a model which you can see, an image you can see, which we have defined that 8,000 we will be able to see, for 8,000 number we will be able to see this particular image. Now what we are doing is, if you, I mean, just notice this, I mean, how x-axis and y-axis is there. If you can see, the y-axis is starting from 25 to 0, and x-axis is starting from 0 to 25. I'll tell you what is the significance for this is, in the later stage. Now we are only printing to showcase, what exactly we have. So what we have done is, print x train. So how many models we have to train? That is 60,000, and dot shape. Shape is 28 comma 28. What is this 28 comma 28 is basically, if you can see, the image coordinates can be only till 28 to 28, 0 to 28. That's how we have given the uh, range to this particular model. And then going forward, now we are reshaping the train and test. So what we're doing currently, I mean, as a layman language, because there are multiple heterogeneous participants, I'll tell you, like, what we're doing is, we are playing this particular model which we have defined now, all the possibility which we'll be defining here, like what can be happen. There can be one more model, there can be 3D model, there can be three more parameters. All those things will be able to train them. So then we are reshaping and training the test sets. What we have, that is a sequential model of TensorFlow.keras, expects data in format of n underscore e, n underscore h, n underscore w, and c. What is parameters are? E is basically examples which we are feeding. Right now what we have done is we are given the example. So this is, we are feeding to that particular model. H is height. Height is 28, if you can see. And width is also 28. That is also width in the graphical model. And C is number of channels. Number of channels we have defined as 1, because there is only two channels, that is 0 and 1. Right now we are given 1 as a channel, so we have enhanced one more capability of this particular model. Then the third step is, I mean, the what we are doing one by one, I mean, if you see all the models, what we are doing is, first step, in any of the data whatever you get, that will be printing, shape of the data, reshaping, training and test data, same things which you have to use. I mean, do not worry about these kind of syntax. The same systems will be used across all the models. First time I know it will be difficult to understand, but if you go through this particular code, it will find very easy to, when you go to one or five six models to work that. Then you go for normalizing the data, where what we are doing is basically, we are not, so normalization in database, what it is called, normalizing is, we are dividing the data into one by one. It's like, how possibility of the data can be, so that each data frame can be divided into one module. So what we are doing here is we have given, that the train, right now we are given defined as float 32. Why we are doing float 32? Because whenever we divide some number by 255, there can be a decimal data. So decimal data has to be stored in some different type. So that's why we have converted x dot train as type to float 32. So that now in a future stage, what we are doing is we are dividing some of the arbitrary number, that is 255, from ranging from 0 to 255. So there can be no error in case we are giving float 32. If this is having string or integer, it will definitely give an error. Then going on the next stage, that is print shape of data and number of images. So here what we're doing is, we're giving the elaboration of all those data, I mean, what exactly we have the data. So these are all print statement, so basically these are the statement which I have written just to make you understand. So there is no significance of this particular print statement. This is just for us to understand what is the data inside which variable. So X train type having shape, this is a particular data, 60,000 records, 28, 28, 1, which I have shown you earlier. Then we have how many data sets we have to train, that is 60,000. What is the test data on which data we will be doing the testing, that is 10,000. What is the maximum value and minimum value? Maximum value is 1.0 and minimum value is 0.2. I told you, like, the channels is only two types, that is 0 and 1. So maximum is X train is 1 and minimum is 0.0. Then we are going for the vector analysis. Here we are categorizing basically on the basis of the shapes. So the syntax for this is, again, we have to use a util class. So first of all, we are converting the class vectors to binary, because computers only able to understand the binary methodologies. So this is an important step. That is a third step of any of the modeling techniques. And how many number of classes we have taken as 10. And then we are doing the categorical cross entropy on loss. So loss percentage, I already told you the example by. Always in any of the model, we used to engulf the loss as well. We whatever, I mean, it's not like machine learning model you train today and all things will be working by tomorrow. There will be some losses which will be losses means there will be some inaccuracy in the data, which will be, I mean, you make your model more robust, you train your model more with more and more data. That's how the loss percentage will be going in a decreasing manner after some time. Then going forward, we have initializing the sequential model, and wherein we have to just model how, I mean, how do we want actually, I mean, there is a model which we have to train, right? So there are three layers which we have said. One is sequential, another is we will be flattening the data, that is in a 2D or 1D area before we building the fully connected layers. Then the last step, we'll be adding two dense layers. That is dense layers, major thing is we experiment of any of the number of neurons for the first dense layer. However, the final dense layer must be having neurons equal to the number of output classes. So it works. And this is how which we are doing. We are again taking the models. So if you have noticed, we after tensorflow.keras, somewhere we are taking util, somewhere taking a model, somewhere we are taking a layer. So that is depending upon your need. So basically, inside the model package, there is a inside this is only we are able to use. Inside layers, we will be able to provide dense. If you will not write layers here, you will not be able to get a intelligence for dense, and you will be getting error for this particular thing. So going forward here, we are just compiling this particular model, whatever we have done. And after compiling this model, all the batches will be getting started, and you have to train the batches. We are taking the batch size at 32. Epochs we have taken as 10. What is it basically? Epochs is a term used in machine learning and indicates the number of passes of the entire training data set the machine learning algorithm has completed. So that's how it's defined as epochs. These are the same terms. I mean, we will understand, like when you write fit in your code, you write the bracket, you'll be automatically able to get in how many parameters you have to pass, and depending upon that parameters you have to give all those size, and depending upon your need. And if the batch size is the whole training data set, then the number of epochs is the number of the iterations. So right now we're taking only 10, but if the batch size, if you calculate 60,000 or 10,000 or 20,000, then you have to give all, because epoch is something iteration, for loop iteration. If you say one match with other 10, second match with other 10, it's a kind of method. So right now, for for the data accuracy, we are using epochs written here. And then after calculating this particular, we will be running this particular model, you will be able to see how the model epochs have been calculated for 10 particular methods. If you observe here, the loss percentage is decreasing by line. If you see the loss percentage at the last line, that is coming out to be only 0.16. So the accuracy of the data is 95%. So that is how the epoch plays a role here. And then once we evaluate, so when we evaluate and see what is the accuracy of the result, it shows how you have fed 313 models, and out of that 313 models have now the data which is accurate without having any kind of losses, and accuracy is 95% without with the loss of 16. We have only given 313 models, and you are able to get accurate results. Now you will be engulfing this particular data with 60,000 records. You will be able to map one-on-one relationship with all the models, whatever models you are having. So this is how, how the machine learning model, any machine learning model works. So major things is you have to make yourself understand how it is starts. Basically, you reshape, you train, that is the pre-processing of the data, how you can pre-process your data, you normalize your data, you segregate the data, then you see how the data is looking like, on what basis we can analyze data, what shape we can do, what category, how we can define the category. So see, there can be a different type of invoices. One can be invoices of PO type of invoice. There can be invoice of some luggage, there some of the products which you have bought from the supermarket. There can be multiple type of invoices. So it's important to first normalize any data, and second point is categorize the data. If you are not categorizing the data, you will not be getting the results appropriate. Then identifying which model you have to use. You have to process the data sequentially, or you have to process parallelly, which model you have to use, what kind of etiquettes which you have to follow, what kind of layers which you have to every. So see, I mean, you can study these layers. Basically, if you dense is something, if you these are basically layers by which the machine learning models already been trained, and you will be able to feed the data, you will be able to achieve the results on those bases. That's it. So this is all from my side for today's session. Thank you so much, everyone, for joining.